Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. So for today's class, we are still in chapter 4, indices, sets and logarithms. So today we are going to continue with subtopic 4.3, laws of logarithms, presented by me, Madam Intan Shizrani. 4.3 Laws of Logarithms. By the end of this video, you should be able to first relate equation in the form of indices and logarithm and hence determine the logarithm of a number. Secondly, you should be able to prove laws of logarithms, and lastly, you should be able to simplify algebraic expression using the laws of logarithms. Okay, the first objective, relating the equation in index form with logarithmic form and determining the logarithmic value of a number. Okay, previously in indices, you know that an equation in index form can be written as n is equal to a to the power of x, where a is greater than 0 and a cannot be 1. And a and x are variable. We can find the value one of the variable if the value of the other two variables are given. Okay. For example, for question A, if 81 is equal to 9 to the power of x, then x is equal to power of 2. Okay, so we substitute x is 2. So 9 to the power of 2 is equal to 81. Okay, for question B, 1000 is equal to a to the power of 3. So how we are going to find the value of a? Means that we have to eliminate power of 3 here. So we have to cube root both sides. Okay, so cube root with cube, so left with a only. Okay, and then cube root of 1000 is equal to 10. Okay, that's how we find the value of a. And lastly, for C, if n is equal to 5 to the power of 3, then n is equal to, you just press calculator, 5 to the power of 3 is 125. Okay, so if a power of m is equal to a power of n, then m is equal to n, since the base is already the same. So if a to the power of m is equal to b to the power of m, then a is equal to b, since the index is already the same, m. Okay, next we move to inquiry 8 activity. Okay, the aim is to relate the equation in index form and logarithmic form. So you can scan this QR code or go to this link, okay, to see the GeoGebra for this activity. And then for the first one, so you will notice the graph of equation in index form. So you press tick the box. Okay, I tried to do it. Okay, this is line y is equal to x, the green color. When I tick a graph box for graph of equation index form, the red color. Okay, I move the cursor for the value of a. Okay, when a is equal to 1, the line is horizontal line here. Okay, next, I take graph of equation in logarithmic form, the blue one. Okay, when a is equal to 1, the blue color disappear. Okay, so this is both of it. Okay, you can try by yourself and observe slowly. Okay, and discuss the finding for this activity. From the result of inquiry 8 just now, it was found that the relationship between equation in index and logarithmic form can be defined as follows. Okay, so this is in logarithmic form. So log n base a is equal to x. Okay, in index form is equal to n equal to a to the power of x, where a greater than 0 and a cannot be 1. From the definition above, it can be concluded that a to the power of 0 is equal to 1, okay, in terms of index form, while in terms of logarithmic form, so log 1 base a is equal to 0 and a to the power of 1 is equal to a, this is index form, while in logarithmic form, so log a base a is equal to 1. Thus, for any real number a greater than 0 and a not equal to 1, the following statement is true. Log 1 base a is equal to 0, while log a base a is equal to 1. Smart tip. So, if we have log a to the power of x base a, it is equal to x. Okay, pocket. Index form 4 to the power of 0 is equal to 1. So in logarithmic form, log 1 base 4 is equal to 0. So 10 to the power of 0 is equal to 1. And in logarithmic form, log 1 base 10 is equal to 0. 7 power of 1 is equal to 7. Log 7 base 7 is equal to 1. 10 to the power of 1 is equal to 10. And lastly, log 10 base 10 is equal to 1. So this is example. Okay, notice that log n base a is defined if n greater than 0 and a greater than 0, a cannot be 1. Okay, for example, so if we have log 0 base 7, log negative 10 base 10, log 2 base 0, and log 13 base 1 are undefined. Okay, since the value of n here, the value of n must be greater than 0, and then the value of a must be greater than 0 and also cannot be 1. Okay, the base of logarithms must be positive. Usually 1 is not used as a base. So here, the small one is the base. Okay, because 1 in index form, 1 to the power of n is equal to 1 for any value of n. Okay, so this one we call it as base in logarithmic form. So the small one is also base. So that's why 1 cannot be used as the base. Okay, because the value of 1 to the power of n is equal to 1. Okay. If a common logarithm value is given for a number, that number can be determined with a scientific calculator. That number is called anti-logarithm or anti-log for short. So you just press shift log. Okay, so if log n base 10 is equal to x, then anti-log x is equal to n. Okay, mathematics pocket. The common logarithm is the logarithm in base 10. For example, so if we have log a base 10, it is equal to log a. Okay, based on the definition of logarithms of a number, we can convert an index equation to the logarithmic form or vice versa. Okay, so the power of index number will become the logarithmic value. Okay, so while the base of the index number will maintain as the base of the logarithm. Okay, as an example, this is in index form. So 16 is equal to 2 to the power of 4. So 4 is the power, right, in index form. So it will become the logarithmic value. So this one, 2 as the base. 2 will become the base in logarithm form. So log 16 base 2 is equal to 4. 4 just now is the power. Okay. So otherwise, we can also convert equation in logarithmic form to index form. So if we have log 16 base 2 is equal to 4, remember that 2 will become the base and 4, the logarithmic value, will become the power. So we will have 16 equal to 2 base to the power of 4. Okay, generally, if we have function x is equal to a to the power of x, then inverse function of x is equal to log x base a. Thus, y is equal to log x base a is the inverse of a to the power of y is equal to x. So you have seen this graph in inquiry 8 just now. So this is the line for y is equal to x. This is the green color. Okay, is the graph for y is equal to a to the power of x, and the blue color is graph for y is equal to log x base a. Okay, example, convert 2 to the power of 4 is equal to 16 to logarithmic form. So this is in index form. So please remember that in previous slide I told you that the power of the index number is the logarithmic value. So the power here 4 becomes the logarithmic value, while the base of the index number is also the base of the logarithm. So this is the base 2. Okay, become the small one. Okay, so this one 2. So the solution, so 2 to the power is equal to 16. Okay, so 2 is the base, so log 16 base 2, while 4 the power becomes the logarithmic value. Okay, next convert log 27 base 3 is equal to 3 to index form. So now logarithmic form becomes the index form. Okay, so the solution, so this one, 3, the logarithmic value becomes the power, right? While the base maintains. So 3 to the power of 3 is equal to 27. Okay, next example. Find the value each of the following. Okay, so for A, log 7 base 10. So you just press calculator. Okay, so this is the answer, 0.8451. Give the answer at least 4 significant figure. And then log 79 base 10, the solution, log 79 base 10. So this one. And lastly, for C, log 3 over 4 power of 3 base 10. So solve the one in the bracket first. So 3 to the power of 3 is 27, and 4 to the power of 3 is 64. And then press the calculator, base 10, you will get the answer, negative 0.3748. Next, find the value of each of the following. So A, log 625 base 5. So this one you cannot press calculator, the usual calculator, since the calculator for log is base 10. But if you use Casio ClassWiz, you can check your answer, since Casio ClassWiz you can change the base. However, you still need to do the solution step by step. Okay, so the first one, you need to let log 625 base 5 is equal to x. So this is the base and this is the logarithmic value, right? So change this form of logarithmic form, okay, this into the index form. So 5 to the power of x. Okay, so 5 is the base of 5 to the power of x. So x logarithmic value becomes the power in index form. So 5 to the power of x is 625. So if you want to solve for the value of the power, so means that this one you have to make it as base 5 as well. So you will get 5 to the power of x is equal to 5 to the power of 4. So the value of x is equal to 4. So the answer, log 625 base 5 is equal to 4. Okay, if you press the calculator, Casio ClassWiz, you will get the answer is equal to 4. Okay, and B, log 7776 base 6. So the same step. Okay, solution, the first one, you change this into index form. So base 6 to the power of y is equal to 7776. So this one change into the base, same base. So 6 to the power of y equal to 6 to the power of 5. So you will get the answer, the power, how to solve it. So y is equal to 5. So the answer, log 7776 base 6 is equal to 5. Okay, next example. Determine the value of x if log x base 5 is equal to 3, and determine the value of y if log y base 3 is equal to 4. Okay, so the solution, this one, okay, so since we are going to solve this one similarly, so you have to change this logarithmic form into index form. So this one, x, so equal to 3, the logarithmic value become the power, and 5 is the base. So x is equal to 5 to the power of 3. So you just press calculator. X is equal to 125. Okay, similar to for our question B. So change into index form. Okay, so I change into in the forms index form. So y is equal to 3, the base 3 to the power of 4. So press the calculator. Y is equal to 81. Okay, then determine the value of each of the following: anti-log 0.1456 and anti-log negative 0.3976. So this one, you just press calculator, shift log, so you will get anti-log only. The answer is equal to 1.3983 for the A, and for B, okay, so negative 0.3976. Okay, so the answer is 0.4003. So please try practice 4.9 question 1 until question number 5. So this one change into logarithmic form, index form. Okay, find the value, which mean for A, B and C you can press the calculator. D, E, F, okay, and G, okay, how to solve it. You can refer the previous example, question 4 and question 5. You just press calculator and then you can check your answer here. Okay, the second objective, proving the laws of logarithm. So the first one, if a, x and y are positive and a is not equal to 1, then the first law is log xy base a is equal to log x base a plus with log y base a. This we call as product law. For B, if we have log x over y base a, so it is equal to log x base a minus with log y base a. This is what we call as division law. And lastly, so if we have log x power of n base a is equal to, so the power we bring to the in front, so we will get n log x base a for any real number n. So this is what we call power law. Okay, each basic law of logarithm above can be proven as follow. So which is product law, division law, and also power law. So let x is equal to a to the power of p and y is to a to the power of q. Then if you want to find p in terms of logarithmic form, so p is equal to log x base a, and q from here becomes q is equal to log y base e. So the first law, which is product law, so we start with xy is equal to, substitute the value of x, which is a to the power of p, multiply with y we substitute becomes a to the power of q. Okay, if this one we apply the index law, so a to the power of p times with a to the power of q, the base is the same, so power we add. Okay, so a to the power of p plus q, and then from the definition of logarithm means that this one, a to the power of p plus q, change into logarithmic form. Okay, then there's log xy base a, so this one, so base is a, this one is already cancelled, so since you just look at this one. Okay, so xy is equal to a, xy is equal to a to the power of p plus q, change into logarithmic form. So log xy base a is equal to, so the power becomes the logarithmic value, and then this one p we substitute here from here, so log x base a, so log xy base a is equal to log x base a plus with the q, when we substitute we get log y base a. So this one is the product law. Okay, the first law. Okay, secondly, so x over y. So substitute x from this statement. So we have 1, 2, 3, 4 here. So x is a to the power of p, while y is equal to a to the power of q. So x over y will get a to the power of p over a to the power of q. Apply the index law. Okay, so p over q with base a. So index law means that the power subtract. So equal to a to the power of p minus with q. And then this one, change this change this, which is x over y is equal to a to the power of p minus q in terms of logarithmic form. So this is become the base. This one is the logarithmic value. So log x y base a is equal to p minus q. This is from the definition of logarithm, means you change into index law. You change index law into logarithmic form. Then substitute the value of p, not the value, substitute equation of p. So here, from here, and q from here, the fourth one. Okay, so log x over y base a is equal to p will get log x base a, while q is log y base a. So this is actually the division law. Okay, sorry, division law. Okay, and lastly, so x to the power of n. So x is a to the power of p. So a to the power of p power of n. So in index law, so a to the power of p times with n. Okay, change this into logarithmic form. So log xn, this one. Okay, log xn base a. So the base is a, is equal to p n. Okay, so this one become the logarithmic value. Okay, from the definition of logarithm. And then this one p is substitute from this one. Okay, so log x to the power of n base a. So p, which is log x base a multiply with n. So I put n in front, so we get this one. So this is what we call as power law. This is how we prove three of the laws, law of logarithm. Okay, next example on how we are going to apply product law, division law, and also power law. Okay, so given the value of log 15 base 5 is 1.6826 and the value of log 4 base 5 is 0.8614. So these two value you have to use in order to solve this question. So that's why they give the information. And the question asks you to determine the value of each of the following: log 60 base 5, log 12 base 5, and log 100 base 5. This one you cannot use a calculator, but if you have calculus with, you can check your answer letter. But you still need to apply all the laws of logarithm in order to solve this question. So for question A, okay, so 60 you have to split it into 15 times with 4, since the question give you the value of log 15 base 5 and also log 4 base 5. So that's why 60 is split it into 15 times 4. Okay, then from here you apply the first law, which is product law. Remember product law, if we have log x y base a becomes with log x base a plus with log y base a. So then we apply the first law. So log 15 base 5 plus with log 4 base 5. This one, the value is already given in the question. So use these two values in order to find the answer. So 1.6826 plus 0.8614. So the answer you will get 2.544. Well, for question B, okay, so we have log 12 base 5. Okay, the given question is 4 and also 15, but this is smaller. So how we are going to do that? Okay, so solution. So 12 comes from 60 divided by 5. Okay, so 5, okay, this one, since 12 is smaller than this one 15, so we are going to apply the division law. Okay, so this one, remember if we have log x over y base a, so it will become log x base a minus with log y base a. So since we have log 60 over 5 base 5, so we are going to write as log 60 base 5 minus with log 5 base 5. This one, if we have log 5 base 5 or log a base a or log 4 base 4, the value of this one is equal to 1. Okay, and this one, log 60 base 5, we already solved in the first question, which is this one. So we are going to use this answer to solve the value. So 2.54544 minus 1, so we will get 1.544. And for question C, we have log 100 base 5. So 100 separated becomes 25 multiplied with 4. Okay, since in the question we have 4, right? So 25 here. Okay, first we have to apply the product law first. Okay, this one. Okay, it will become like this. So log 25 base 5 plus with log 4 base 5. And then this one, 25, we can apply the third law, which is power law, but this one we have to make it in terms of power, which is 5 to the power of 2 is 25. So we will get like this. So log 5 to the power of 2 base 5 plus with log 4 base 5. Okay, so how we are going to solve this? Okay, remember that smart tips before this. So if we have log a to the power of x base a, so the answer should be x. So if we have log 5 base 5 to the power of 2, the answer should be 2. Or we can apply the power law, in which power we bring to in front. So we will get this one, power bring to in front. So log x to the power of n base a is equal to n log x base a. So we are going to write as, to bring in front, 2 log 5 base 5. This one we get from the question, which is 0.8614. And this one, the value of log 5 base 5 is actually 1. So we just left with 1. 2 plus 0.8614. The answer should be 2.8614. Or you can just left your answer as at least 4 significant figure and two decimal place. Okay, next example, find the value of each of the following without using a calculator. So means that you have to apply the laws of logarithm, product law, division law, and also power law. Okay, so for question A, so we have log 750 base 5 minus with log 6 base 5. So for solution A, so this one you have to apply the division law, since this one is involve subtraction. So it will become log 750 divided by 6 base 5. So 750 divided by 6 base 5 is log 125 base 5. So how we are going to solve this one? So this one, you can write it as 5 to the power of 3. Remember that if we have log a base a or log 5 base 5, so the value should be, this one is 1. But after this step, you have to apply power law in which 3 you bring in front, so it will 3 log 5 base 5. So this one is 1. So the answer should be 3. Okay, or if we have log a to the power of x base a, okay, the value should be x. Okay, b, log 8 base 3 plus with log 6 base 3 2, okay, minus with log 96 base 9, log 96 over 9 base 3. So this one, okay, so the second one, sorry, this one you have to apply the power law while in order to write before you solve this kind of question. So log 8 base 3 plus with log 6 2 you bring becomes the power. So 6 to the power of 2 base 3 minus with log 96 over 9 base 3. And then this you are going to apply product law, subtraction, you apply division law. Okay, so just write since the base is already the same, so 8 multiplied with 6 to the power of 2, which is 36, divide by 96 over 9. So press this one, you have to calculate, so you will get 27. So 27 can be written as base 3. So 3 to the power of 3 is 27. So we have log 3 to the power of 3 base 3. So 3, you apply the power law, bring it in front, so you will get 3 log 3 base 3. So this one is 1, right? Okay, so the answer is 3. Okay, so please try some practice 4.10, question number 1 and also question number 2, and then you can check your answer here. Okay, next, the third objective and the last objective for today's class is simplifying algebraic expression using the laws of logarithms. Algebraic expression involving logarithm can be simplified using the laws of logarithm. Example, express the following as single logarithm. So if we have log x base a plus with log 3 log y base a, so the solution, first 3 you write it as power, right? So we have log x base a plus log y to the power of 3 base a. So this one you apply product law, so it will becomes log xy to the power of 3 base a. So that's how we simplify this kind of question using laws of logarithm. Next example, express the following as single logarithms. So we have 2 log x base a minus with 1 over 2 log y base a. So remember, so this one it involves power law and also division law. So the solution, so the first one you need to do is the integer in front of logarithm here, log, so become the power. So log x to the power of 2 base a, and this one also 1 over 2 becomes the power of y. So log y to the power of 1 over 2 base a. So this one you can apply division law because it involves subtraction. So the answer should be log x to the power of 2 over y 1 over 2, which is y to the power of 1 over 2 is actually square root base a. So that's how we solve this kind of question to form a single logarithm. Okay, for question C, we have 2 log x base 3 plus with log y base 3 minus with 1. Okay, so the solution, first you need to the integer becomes the power of x. Okay, and 1 here, since this one is in terms of log with base 3, so 1 you should make it as base 3 as well, which is log 3 base 3 is equal to 1, right? So we write it as log x to the power of 2 base 3 plus with log y base 3 minus with log 3 base 3. And then you can apply product law and also division law, since product law involves addition and division law involves subtraction. So we have log x to the power of 2 y, okay, which is this one, x to the power of 2 multiplied with y is x square y, okay, over 3, and the base is log base 3. Okay, next we move to the last example for today's class. So given that p log 2 base b, q is log 3 base b, and r is log 5 base b. So we have to write these 4 questions in terms of p, q, and also r. Okay, these 4 questions, sorry. Okay, so the first one, solution. So we have log 6 base b. So however, in the question it only give you log 2, 3, and also 5 with base b. So 6 you have to split it into log 2 times with 3. So this one you have to apply product law, in which it becomes log 2 base b plus with log 3 base b. So this one, the value already given in the question, which is log 2 base b is actually p, and log 3 base b is actually q. So p plus q is the answer. For question B, we have log 45 base b. Okay, as usual, you have to split 45, so it becomes 9 times 5. So however, 9 in the question we only have 2, 3, and also 5. So 9 should be 3. Okay, how we are going to do that? So we are 3 to the power of 3 is actually 9. So this one we apply product law. So log 3 to the power of 2 base b plus with log 5 base b. So 2 you bring it in front, in which we apply power law. So you write as 2 log 3 base b plus with log 5 base b. So this one already given in the question. So 2q, since 3 log 3 base b is actually q, and log 5 base b is actually r. So 2q plus r, the answer. Okay, for question C, this one, log 0.22222 base b is actually log 2 over 9. How we are going to solve this one? Remember in 4.2 loss offset, you already learned how to do this. Okay, a is 0.2222. We let it as equation 1. Okay, so 100a is equal to 22.2222. Okay, this one is equation 2, and then subtract with equation 2 with equation 1, in which 100 minus a, you will get 99a. So 22.2222 minus with the 0.222, you will get 22. So a, you will get 22 over 91, in which a is equal to 2 over 9. So that's how we get 0.2222 is actually 2 over 9. Okay, here, from here, since this is over division law, so we are going to apply it, and becomes log 2 base b minus with log 9 base b. So this one, 9, you have to make it in terms in number of 3. So it will get log 2 base b minus with log 3 to the power of 2 base b. So this one we apply power law, in which 2 we bring in front. So you will get log 2 base b minus with 2 log 3 base b. So this one already given in the question. So p minus with this one 2q. That's the answer. And lastly, for question D, log 5 to the power of 5 square root multiplied with square root of 3 divided by 2, in which we are going to apply product law. This one is product law, 5 multiplied with square root of 3, and also division law here. So this one we split it, it will become log 5 base b plus, okay, with log square root of 3 base b, and then this one divide becomes subtract log 2 base b, and then this one 3 is actually 3 to the power of 1 over 2. Okay, so this one is actually 3 to the power of 1 over 2. So in power law, 1 over 2 we bring in front, so that's how we get log 5 base b. Okay, 1 over 2 you bring in front, we will get 1 over 2 log 3 base b minus with log 2 base b. Okay, and then you just substitute the value given in the question, in which log 5 base b is actually r plus 1 over 2 q minus with p. So that's the answer for question D. Okay, last exercise for today's class. Please try sub-practice 4.11 in your textbook for question 1 and also question 2. Express this expression in single form, and also for question 2 you can refer previous slide, okay, in order to solve question number 2, and then check your answer here. Okay, that's all from me for today's class. Okay, so in the next class, you are going to continue with subtopic 4.3, which is laws of logarithm, by focusing on 4.3.4 until 4.3.5 only, presented by Muslimah. That's all from me. Thank you. Bye-bye. Assalamualaikum.